Welcome to my channel. Today, let's delve into computer hardware, which is the term used for physical components of a computer. One central processing unit or CPU is the primary component of computer hardware responsible for executing instructions and performing calculations. Often referred to as the brain of the computer, the CPU processes data by fetching instructions from memory, decoding them, executing the necessary operations, and then storing the results. It operates at high speeds and is a crucial element in determining a computer's overall performance. CPUs come in various architectures and are characterized by factors like clock speed, number of cores, and cache size, all of which contribute to their processing capabilities. Two storage devices are devices that store and retrieve data. Computer storage involves various devices and technologies for storing and retrieving data. Here are the components. Hard disk drives or HDDs use magnetic storage to store data on spinning disks. They offer high capacity storage at a relatively lower cost, but they may be slower than other storage types. Solid state drives or SSDs use NAND-based flash memory for data storage. They are faster, more durable, and consume less power than HDDs. SSDs are commonly used for improved performance in both desktops and laptops. RAM or random access memory is volatile memory used for temporarily storing data that the CPU needs frequently and quickly. Unlike storage devices, RAM loses its data when the power is turned off. Cache memory, which is a smaller and faster type of volatile memory located closer to the CPU. It stores frequently accessed instructions and data to reduce the time needed to fetch them from the main memory. Optical drives. While less common today, optical drives like CD, DVD, and Blu-ray drives were traditionally used for reading and writing data on optical discs. Cloud storage involves storing data on remote servers accessed over the internet. Services like Dropbox, Google Drive, and OneDrive provide convenient and scalable options for users to store and retrieve data from anywhere. Network attached storage or NAS devices are specialized file servers connected to a network. They provide shared storage accessible by multiple users and devices. Flash drives. These portable storage devices use flash memory for data storage. They are small, durable, and convenient for transferring data between computers. Overall, the choice of storage depends on factors like speed, capacity, cost, and purpose. Modern systems often use a combination of storage types to balance performance and capacity requirements. 3. Motherboard is the main circuit board of a computer, and it serves as the central platform connecting various hardware components. Here are the key aspects of a motherboard. Form factor. Motherboards come in different form factors, indicating their physical size and layout. Common form factors include ATX or Advanced Technology Extended, Micro ATX, and Mini ITX. CPU socket. The central processing unit socket is a specific slot on the motherboard where the CPU is installed. It varies based on the CPU's design and manufacturer. RAM slots. These slots hold the system's RAM or random access memory modules, allowing the motherboard to access and manage volatile memory. Expansion slots. These slots accommodate expansion cards such as graphic cards, sound cards, and network cards, enhancing the computer's capabilities. Chipset. The chipset is a set of integrated circuits that manage communication between the CPU, RAM, storage devices, and other peripherals. It plays a crucial role in the motherboard's functionality. Connectors. Motherboards feature various connectors for peripheral devices, including USB ports, SATA ports, and connecting storage drives and audio jacks. Basic Input-Output System or BIOS or Unified Extensible Firmware Interface or UEFI is firmware that initializes hardware during the boot process and provides a basic interface for configuring system settings. Power connectors. Motherboards have connectors for receiving power from the power supply unit or PSU and distributing it to different components. Networking. Some motherboards include built-in Ethernet ports for wired network connectivity connectivity, and others may have integrated Wi-Fi capabilities. Input-output ports or I/O ports on the motherboard's rear panel allows for connection to external devices including USB ports, audio jacks, and video outputs. Choosing a motherboard depends on factors like compatibility with the CPU, expansion slots for future upgrades, and the overall system requirements. It serves as a crucial foundation for building and upgrading computer systems. 4. Graphics Processing Unit or GPU is a specialized electronic circuit designed to accelerate the processing of images and videos for display. It handles graphics processing tasks crucial for gaming and visual applications. The key aspects of GPUs are graphic rendering. The primary function of a GPU is rendering graphics and visual content. It handles complex mathematical calculations required for displaying images and videos on a screen. Parallel processing. GPUs excel at parallel processing, enabling them to perform multiple tasks simultaneously. This makes them particularly efficient for rendering graphics, as many graphical tasks can be processed concurrently. Shader cores. Modern GPUs contain shader cores, which are programmable units responsible for executing complex mathematical operations related to graphics rendering. Shader cores are crucial for rendering realistic lighting, shadows, and textures in video games and other visual applications. Video memory or VRAM. GPUs have dedicated video memory to store graphical data and textures. VRAM's high-speed access allows for quick retrieval of graphical elements, contributing to smooth visual performance. CUDA cores or NVIDIA or stream processors or AMD. These are parallel processing units within the GPU responsible for executing specific tasks. They contribute to the overall processing power of the GPU. GPGPU or general purpose computing on graphics processing units. Beyond graphics rendering, modern GPUs are used for general purpose computing tasks such as scientific simulations, machine learning, and data processing. Graphics APIs. GPUs interface with software through graphics APIs or application programming interfaces like DirectX and OpenGL. These APIs allow developers to create applications that leverage the graphical capabilities of GPUs. Display outputs. GPUs provide output ports for connecting monitors and other display devices. Common outputs include HDMI, DisplayPort, and DVI. Dedicated versus integrated GPUs. Dedicated GPUs like those from NVIDIA or AMD are standalone cards specifically designed for graphics processing. Integrated GPUs are built into the computer's central processing unit and share system memory. Gaming and graphics workloads. GPUs play a crucial role in gaming, video editing, 3D modeling, and other graphics-intensive tasks. High-end GPUs are often sought after by gamers and professionals for improved graphical performance. Prominent GPU manufacturers include NVIDIA and AMD, each offering a range of GPUs catering to different performance levels and applications. 5. Power Supply Unit or PSU. A PSU is a crucial component in a computer that converts electrical power from an outlet into a form usable by the computer's internal components. Here are the key aspects of a PSU. Input and out. The PSU takes electrical power from a standard wall outlet as an input and provides regulated power outputs to various components within the computer. Voltage rails. PSUs provide different voltage levels on separate rails to supply power to the different components. Common rails include plus 3.3 volts, plus 5 volts, and plus 12 volts. Wattage. The wattage rating of a PSU indicates its maximum power output capacity. It needs to provide sufficient power for all connected components. Higher wattage is often necessary for systems with powerful CPUs and graphic cards. Efficiency. PSU efficiency represents how well it converts input power into usable output power. Efficiency is expressed as a percentage, and higher efficiency ratings result in less wasted energy as heat. Form factor. PSUs come in various form factors such as ATX, SFX, and TFX, which determine their physical physical size and compatibility with different computer cases. Modularity. Some PSUs offer modular cabling, allowing users to connect only the necessary cables, reducing cable clutter and improving airflow within the computer case. Connectors. PSUs come with a variety of connectors for powering different components, including the motherboard, CPU, GPU, storage devices, and peripherals. Standard connectors include 24-pin ATX, 8-pin EPS for CPU power, and PCIe connectors for graphic cards. 80+ certification. This certification indicates the PSU's energy efficiency. Higher certification levels such as 80+ bronze, silver, gold, platinum, and titanium represents higher efficiency standards. Active power factor correction. Active PFC helps improve power efficiency by correcting the power factor, reducing energy waste, and enhancing compatibility with different electrical systems. Over voltage and over current protection. Good PSUs include protection mechanisms that prevent damage to connected components in case of over voltage or over current situations. Choosing a PSU involves considering the power requirements of the components in your system and ensuring that the PSU provides sufficient power with good efficiency and reliability. PSU quality is crucial for the stability and longevity of a computer system. 6. Peripheral devices. Peripheral devices are external hardware components connected to a computer that expand its functionality and provide additional input, output, or storage capabilities. Here are some common types of peripheral devices. Input devices. Keyboard allows the users to input text and command. Mouse enables pointing and clicking to interact with the graphical user interface. Scanner converts physical documents or images into digital format. Output devices. Monitor or display presents visual output to the user. Printer produces hard copies of digital documents. Speakers output audio for music, videos, and other multimedia content. Storage devices. External hard drive provides additional storage space outside the computer. USB flash drive, portable storage device for transferring and storing data. Memory card reader allows access to data on memory cards from cameras or other devices. Communication devices. Modem connects to the internet via phone lines or other communication channels. Network interface card or NIC enables wired or wireless network connectivity. Input-output devices or I/O devices. Webcam captures video for video conferencing or recording. Microphone captures audio for voice input or recording. Touch screen allows users to interact directly with the display by touching it. Game controllers, joystick, gamepad, steering wheel, input devices designed for gaming. Virtual reality or VR controllers used in virtual reality gaming and applications. Biometric devices. Fingerprint scanner verifies identity based on fingerprint patterns. Facial recognition camera identifies individuals based on facial features. Point of sale or POS devices. Barcode scanner reads barcodes for inventory and scales tracking. Card reader reads credit or debit cards for financial transactions. Multifunction devices. All-in-one printer combines printing, scanning, copying, and faxing functions. Smart TVs integrate television functions with internet connectivity and applications. Peripheral devices enhance the capabilities of a computer system, allowing users to interact with the digital world more effectively and perform a diverse range of tasks. 7. Networking hardware. Networking hardware consists of physical devices that facilitate communication and data transfer within a computer network. These devices help manage and maintain network connections. Devices facilitating network connectivity include network cards and routers. Here are key types of network hardware. Router directs data traffic between different networks and ensures that information reaches its destination efficiently. Switch connects multiple devices within a local area network or LAN using MAC addresses to forward data to the appropriate device. Hub, an older device that connects multiple network devices, but it operates at the physical layer and lacks the intelligence of a switch. Modem converts digital data from a computer into a signal suitable for transmission over communication lines, for example, from digital to analog for DSL. Access point provides wireless connectivity in a network, allowing Wi-Fi enabled devices to connect to a wired network. Network interface card or NIC, hardware that allows computers to connect to a network. It can be integrated into the motherboard or added as a separate expansion card. Firewall protects a network by monitoring and controlling incoming and outgoing network traffic based on predetermined security rules. Bridge connects two or more network segments, making them function as a single network. Repeater extends the range of a wireless network by amplifying and retransmitting signals. Gateway connects different types of networks, translating data between different network protocols. These network hardware devices work together to create a functional and efficient computer network, enabling communication and data exchange between connected devices.